Good evening, everyone. Today's lecture is on UAV photogrammetry and its application. So for this lecture, I expect a minimum basic understanding of photogrammetry, what basically is a photogrammetry, what are the basic requirements of the photogrammetry. These basics I expect that some you need to have. However, I briefly touch upon the basics and other things of the photogrammetry also, but but the major focus will be on how we can customize or how we can exploit this UAV for photogrammetry. That would be the focus of this lecture. However, I would cover what actually is a photogrammetry if somebody is listening the photogrammetry for the first time. The overview of the lecture is briefly I'll touch upon what actually is a photogrammetry and the platforms that are there for the photogrammetry and the different modes in which we can acquire the photographs so that we can perform the photogrammetry and then get the 3D measurements on the ground, and then how the UAVs can be used as a platform specifically for doing the photogrammetry. That would be the next part for the discussion, and then what actually the steps will be involved for doing the photogrammetric processing will be discussed later on. And then I'll talk about something called the orthophoto. If you are familiar with the photogrammetry, you will understand this term. Otherwise, for those who are new to this photogrammetry, then I'll also explain them what actually is an orthophoto, how it is orthophoto, because without generating an orthophoto, you cannot do any measurement on the photo. And then once having this background, then I'll take you through the studies and the possible application that one can think of. And in this lecture I have some got this content from internet, from various sources of the internet. So firstly, starting with the photogrammetry. So before going to the definition and other things of the photogrammetry, I would like to brief you all where the photogrammetry stands as a remote sensing. So by this time, you all must be aware that remote sensing is basically to collect the data. It only gives you the data, and ultimately we do some processing so that we can extract the information. And why we are extracting the information is to basically do the decision making, and basically we do the decision making for preserving our resources. Okay, so now what kind of information that we can draw from the remote sensing data? Regarding that, we can classify the remote sensing broadly into two categories. One, remote sensing, which is particularly dealing with identification of an object, what that particular object is, what are spectral qualities. Or the other domain can be which is basically trying to give you the aspects of the terrain. Like somebody may need to find out how much is the area, what is the length, what is the angle between the two lines on the ground or two features on the ground. These may be some of the requirements. So the other category of the remote sensing, that is basically is trying to understand the geometry of the ground. In that particular category, this photogrammetry falls in. So from the photogrammetry, what I expect is basically the geometric aspects of the terrain. Here I am not going to analyze what is that particular feature, rather than how much is that feature on the ground. What is its area, what is its volume, what is its length, what is its bearing with respect to it extract from the photogrammetry. Okay, so to look at the textbook definition, it is very broad, but if I have to understand, photogrammetry is which uses 2D images, and using these 2D images, we try to extract the 3D information and measure the three dimensions on the ground. This is the ultimate aim of the photogrammetry. And in order to do that, actually the scene is in 3D, or the terrain is 3D, and this 3D terrain we project it onto a CCD array of the camera where we get the image, and using this image we try to derive the 3D of the scene or the terrain. This is what we try to do in photogrammetry. Okay, and this is how your image looks. So your image is basically a central projection or a perspective projection of the 3D scene that you capture. And once we have this image, from this overlapping images, we try to derive the 3D scene. Okay, so on the image, as you all might be aware, that image is basically consisting of the pixels, and each pixel has got a row and column. If I define the x and y axis within the image, then I have x and y coordinate for each pixel in the image, and from this x and y coordinate of a pixel in the image, I should be able to derive what is the coordinate on the ground. And once if I do it for all the pixels, then basically I'm generating the 3D of the ground. And from this 3D, we try to make all the measurements. Maybe it's a three-dimensional measurement like volume, two-dimensional measurement like area, or simply the length. Okay, so the ultimate deliverables that you can expect from the photogrammetry is the geometrical measurements. So photogrammetry never aims to identify an object, rather it aims to only find out the geometrical lengths on the ground. Okay. However, an object can also be identified based upon its geometry. Like if I have to differentiate a tree from the building, normally the buildings are rectangular in shape, tree is irregular. So based upon the shape we can identify, but here we are not looking at the radiance or the reflectance values so that we differentiate the features. Okay. So having this basic understanding, now people are talking about the UAV photogrammetry, and this has become a hot area. But as a person in this area for more than 8 years, I can say that this is not a new thing. But in the olden days also, people used to attach the cameras on the pigeon, and then the pigeons were trained to flow over that area, and then the camera was programmed to take the photographs at a regular interval. And using these photographs, the people used to do the surveillance. Here the photographs are not taken in a proper way, so that you do the photogrammetry. There are certain requirements how the photograph should be acquired, so that you do the photogrammetry. But in such case, you get the photographs for which are sufficient to do the surveillance. Okay, so you can see the photograph like this. So it has poor geometric quality and also the radiometric quality, but it was sufficient to get some information on the ground. So what we have done nowadays, what people do when they call it as the UAV remote sensing or UAV photogrammetry in specific for this lecture, is simply we have modified this in the form by attaching the engines and the propeller and other components which might have been told by Mr. Chirag in yesterday's lecture, so that we have more control on this platform. So once we control this platform, the photographs that we get are also acquired as desired. Okay, so that these photographs has got good radiometric quality and also the geometric quality. Okay, so what we have basically do is we attach a camera to this platform, whether it's a fixed wing, whether it is a rotary type of platform that you choose. There are various platforms. I'll also discuss what platform suits for the photogrammetry. So you choose a platform, simply attach a camera on it, and then ask this particular UAV to fly as per the predefined flight path, and you get the photographs. Okay, and you can also decide how much is the overlap between the two photographs. So when one photograph is taken, the UAV moves to the second location and takes the another photograph. Now the photogrammetry needs that these two photographs should have some overlap. So how much overlap should be there between these two photographs? The user can predefine it, and accordingly the flight plan can be made. I will also discuss something on the flight planning aspects. What are the different things one should look once he is doing the flight planning mission for photogrammetry. Okay, so with just by replacing the pigeon with this, what we are doing is we are having more control on it, and we operate it so that we get the desired level of accuracy is on us. Okay, so this is an older way of doing the photography, and this is a new way. The only difference I see is that otherwise the photogrammetry has been there for quite long, and also the aerial photogrammetry is quite long. The only difference is how you maneuver this UAV to get the desired acquisition. That is the only thing here. Okay, so if you look at the photogrammetry that we perform, you might be aware that there are three conventional platforms: spaceborne, airborne, and terrestrial. Okay, since spaceborne is quite away from the UAV, so I just thought of giving you a comparison of the conventional aerial platform with the close range or terrestrial platform and the UAV. Okay, how it different from from all these perspectives when we compare it with the aerial platform and with the closed end platform. Okay, so in terms of planning, let us look at in terms of planning how these aerial platform, closed-end photograph platform, and UAVs are different. Is the planning in aerial manned missions is done in a semi-automatic mode. Okay, whereas in closed-end photogrammetry, it is normally done in manual mode. If you have a particular building with which you want to do the geometrical measurement or create a 3D model of that particular building, we do the planning in a manual mode only normally. However, this can also be automated if you want to achieve a required accuracy. Then there are network of the camera. Using those network designs, you can achieve the required accuracy. Okay, so most of the time it is manual, but you can also do the planning where you from where you have to take the photograph so that you desired level of accuracy. The other thing is the UAVs. UAVs, as you might be aware by now, that it has got an autopilot, and you can configure this autopilot how the UAV should go and how it should behave when it is taking a photograph. So entire process of data acquisition and planning can be done in a automatic mode. Now coming to the data acquisition, how you acquire the photographs. In case of aerial, it is assisted or a manual, whereas in case of close range, it is autonomous or assisted or manual. In either of these ways, we can do it. Whereas in case of UAV, we can also do it autonomous. It means that the camera itself, you are programming, or autopilot, you are itself programming in such a way that it is triggering the camera to take the photograph, or it can be assisted or it can be manual. What I mean by manual is once you fly the drone, you can trigger from the ground segment when you want to take the photograph. Now the size of area, how much area we are going to do the photogrammetric processing. Normally for the conventional man platform, the area coverage will be more. Normally, nobody does this aerial platform, conventional aerial platform, for a smaller area. Say suppose I want to do it only for this IRS campus itself, then I don't go for the aerial conventional manned missions because it is very costly for me. So normally for larger areas which are of few kilometers, for that we go for the conventional, that would be better. And close range are normally for very short areas, very small spans, like which are having an area from few squares of millimeters to few square meters. Otherwise, it will be a very tedious process. Otherwise, you can also do, nobody stops you from doing for few kilometers, but it is only that it is very laborious, it is very time consuming, and it will be very costly affair. However, the closed-end photogrammetry has got its own advantages, that you get the terrestrial view. From the aerial, you can only get the aerial view. This is the only difference. Whereas the UAVs normally can be done for few squares of kilometers to few square meters. Okay. Now talking about the resolution of the image, that's what I am talking about. The ground sampling distance, 1 pixel on the ground will be how much? This is what we call in terms of the image resolution. When I look at the image resolution, I can get it from few centimeters to from few meters from conventional platform, which will be flying at an altitude of few kilometers from the ground. Closed-end photogrammetry, the resolution of the pixel size will be few millimeters to few decimeters. Whereas for UAV, it will be millimeters to meters. Again, how much away you are from the ground or from the scene. This basically dictates this thing. And the distance to the object. Okay, normally the distance for the aerial conventional platform is from 100 meters. This is very low, but you can have a manned mission from 100 meters to tens of kilometers. Whereas in case of close range, we call the close range photography when the photography is done less than 300 meters. So it can be from few centimeters away from the scene to 300 meters. Anything beyond, we call it as the aerial photogrammetry or normal photogrammetry. In case of UAV, we can configure the UAV to fly few meters to few kilometers. And regarding the orientation of the platform for acquiring the photographs, the normal conventional aerial platform, they are normal. That means to say when the aircraft is moving like this, it takes the photograph in the normal direction. Whereas the enclosed in photogrammetry, we can do it either in a norm mode or in a oblique mode also like this. Whereas in case of UAV, the UAVs can be configured to look at the ground like this or like this. Again, you can take the help of the autopilot to maneuver this UAV. And now talking about the final deliverables in terms of the absolute accuracy. Absolute accuracy, whenever say accuracy in the photogrammetry is the accuracy of the measurements, whether it is a length measurement, area measurement or volume measurement. Here the accuracy is the accuracy of the geometric measurements only. So here we can expect, in case of the aerial, we can expect an accuracy from ranging from few centimeters to the decimeter. In case of close range, it can go from millimeters to meters. However, there are some photogrammetry called the industrial photogrammetry, with which you can also get an accuracy up to micrometer level of accuracy is also possible. However, you have to take certain extra while taking the photographs, and also you need some extra hardwares so that you get an accuracy of order of few micrometers also it is possible. Whereas in case of the UAVs, the accuracies will be ranging from few centimeters to tens of meters. And the image block photographs to 1,000 photographs in case of aerial, whether in case of the close-end photograph it can be from 1 to 500, and in UAV it is from 1 to 1,000. And if you look at the special applications for which you can use these platforms, is this aerial platform can be used normally for large scale area mapping when the area is very large, and for such applications really you can make use of this manned missions. So the applications can be the mapping for larger areas, especially for the forest which has got very large area, and for studying the glaciology, 3D city modeling of a larger city. If it is a small town which is having few square kilometers, then you can make use of UAVs also. The closed-end photogrammetry applications are basically which are of very small area, which are confined to the small areas, and the object size should also be small. Okay, so the applications are like the archaeological documentation of the cultural heritage sites. Now, this is one of the hottest area where we try to digitally document these archaeological sites so that whenever there is a disaster, we can think of even. And 3D modeling of the building, provided the building is of a very small dimension, and architectural drawing extraction, and also the industrial where the demand is of very high level of whereas the possible applications of the UAV could be ranging from small area to the larger area, something like the archaeological documentation. I will also discuss you one of the applications separately on this archaeological documentation, monitoring of the hazards, 3D modeling of the building and the object, and special applications can be over those areas which are inaccessible and which are dangerous areas where the manned missions cannot be or not possible, and performing the terrestrial photogrammetry is not possible because of their inaccessibility. So really, which are those areas which are remote and which cannot be accessed? For such areas, the UAVs can be very perfectly used. They can be automatically programmed to go there, acquire the data as per your requirement, and then come back safely. So this way, UAV provides us more functionalities when compared to the aerial as well as the close range. However, it has got its own negatives also, which will also I will discuss in the coming slide. Now, when I talking about the drones or UAVs, by this time you must be aware the various types of drones, various categories of the drones. The drones can be propellers, the propeller type or the non-propeller type. Within the propeller type, you can have a quadrotor or a fixed wing. Whereas if you do not want to have any propeller, you can have the drones like balloons, airship, glider. These are all the drones or UAVs which do not have the propeller. Or else the propeller type can be the fixed wing glider, propeller and jet engines, rotor kites, the kites which have got a rotor also, single rotor, coaxial rotor and quad rotor, multicopters. These are all the various possible platforms that are available to you, which can be a category of UAVs. Now let us look at what are the different features these platforms give us once we are trying to photogrammetry using these platforms. So for performing the photogrammetry can be certain parameters one can think of. The first one is the range. Range is from the ground. From the ground station, how far your UAV can go. Go farther, or whether it is possible that to do in a shorter range. The other thing is the endurance. Endurance is the time for which the drone can fly without discharging its battery. So this is basically dependent on the battery. And weather dependency is also more important because the photographs that we acquire for doing the photogrammetry should not be blurred. Like when the platform is shaky and you take a photograph, obviously you get a blurred image. Now that blurred image is of no use to perform the photogrammetry. And also the maneuverability. How well you can maneuver this platform so that you can acquire the photograph as per your requirement. So if we have to compare against these 5 parameters of with these all platforms, you can see that balloon zero range, because the once you launch a balloon and keep a camera on it, the balloon will be tagged with a rope or with a thread, and it can only have a very less area just above the user. This is the limitation. So the range is very low when you compare it with the other platforms, but it has got very high endurance. You can keep the balloon in the airspace for quite a long time. And weather dependency is also low. Even in a windy condition, the balloon can stay stable. Maneuverability is also very low. Okay, you cannot maneuver the balloon. Now coming to the airships. Airships has got a longer range. You can ask the airship to go very far away from your ground station and collect the data. Endurance is also very high for this, but the weather dependency or weather condition is low. Whenever the weather is very shaky, then the platform get turbulated. And the maneuverability is medium. It's not so high, it's not so medium. Now talking about the gliders or the kite, it has got a bit medium kind of a range, very low endurance, and weather dependency is also very low. Maneuverability is also low in this. Fixed wing has got a high range. You can send this fixed wing gliders to a longer distance. Is also a kind of medium. It also depends upon the battery, that the amount of the charging that you have in the battery. Weather dependency is also medium. The maneuverability is also medium. Propeller and jet engines, they have very long range. Endurance is also good. Weather dependency is medium. Maneuverability is also medium. Rotor kites, again this has got a high range. Endurance is also medium. The weather dependency is low. Maneuverability is also medium. Single rotor, you can see a lot of comparisons here. So comparing all these things, we can pick up the suitable platform for doing the photogrammetry. So from this particular thing, we can see that either the quad rotor or the fixed wing are suitable for doing the photogrammetry. So if you look at the multicopter here, it has got a medium range, and the endurance is also medium. The weather dependency is medium, and the maneuverability is very high. You can maneuver it as you want. Whereas fixed wings, they cannot be maneuvered. They go flat. They can only be brought down or taken up, but they cannot be maneuvered as the maneuvering when we compare it with the multi-rotor. So out of this, what we can go with is a fixed wing or the multicopter. But if your area is very small and you want to have very high endurance, just like if you want to do the traffic monitor only over one junction, then probably you can launch a balloon, put a camera on it, and then focus only on that particular junction. So for such applications, the balloons can also work very well. But the multicopters, people try to see that they shake more when there is a windy condition. But for such multicopters, we have got something called the gimbals. These gimbals can really absorb the shock that you get, or the disturbance, turbulent disturbance that you get from the wind will be completely absorbed by these gimbals. Okay, so using gimbals, you can also make this as zero nowadays. So the possible advantages of UAV, especially for the photogrammetry, is that for photogrammetry we want the images to be taken very stable, and also they should have higher resolution. These are the some of the requirements of the photograph for performing the photogrammetry. So if you see very high spatial resolution, they can be brought down for a given focal length, and then the photography can be done with a very high spatial resolution. And also if you want to do some dynamic changes within the scene, then the UAVs can also offer you the temporal resolution also very high. And they can be used for covering the larger areas when compared to the ground, but definitely lesser area when compared to the conventional aerial manned missions. And also you can provide longer dwell time over your area of interest. And these are quick and easy to deploy when once you are comparing to the manned mission. The manned missions may take 1 or 2 days to deploy, to plan and deploy it, but these can be very easily deployed within few hours. As soon as there is an emergency, within 1 or 2 hours you can deploy this drone to your desired area and acquire the data, and then the photogrammetry can also be performed within few hours. So the process from deployment to data acquisition to the entire the DEM generation or the end product generation can happen in few hours. And these UAVs also provide us the ability to operate in hostile environments like smoke, ash, active and volcanic kind of conditions where the manned missions cannot be really put on. One of the example could be is a forest fire. Whenever there is a forest fire, you can send the UAV very quickly and also at a lower height, and then get the data how the fire is basically flowing from one area to another area, and also you can do the predictive modeling in a very short time, and then the effective measurements can be also taken. And the UAVs has got variety kind of platform that I have discussed in the the previous slide. And by making a mix and match, you can also make your hybrid kind of a platform. Nowadays there are some UAVs which have got the quadcopter capabilities and also the fixed wing. Okay, for fixed wing you need a takeoff space and also landing space. So now what people are doing is they are mixing both the things, the quadrotor and also the fixed wing. It lifts with the quadrotor, and once it achieves the desired accuracy, desired velocity, it will take the help of the fixed wing so that the endurance is more. So just by making a mix and match, you can have a better platform for photogrammetry also. The fixed wings are stable, so the photography will be stable, and they are relatively lower in cost when compared to the other modes of data acquisition. And the UAV systems also enable us more flexibility in terms of acquiring the data. Like we can have the normal photography, oblique photography and terrestrial photography. All modes of photography can be configured using this drone. This is one of the plus point for us. And the normally the manned mission, they go at a fixed height, but but whereas the UAVs can be configured to go the height as per the ground. So the manned mission fly at constant height unlike UAV, and therefore they are not suitable for the terrain which are undulating. Once you acquire the photograph over the undulating terrain, now the pixel size and the ground sampling distance will be varying across the ground, which is not suitable for doing the photogrammetry. In photogrammetry, we do not allow the scale variation between the two photographs more than 10%. But once you used a fixed wing or a conventional a platform for doing the photography on the undulating terrain, the scale variations will be very high, and that may not be suitable for doing the photogrammetry. So by using the drones, I can configure it as per the terrain. So this part has to go in the flight planning, and then the autopilot can be instructed accordingly or programmed accordingly. Whenever it is here, at what height it should be there, and as it go away, at what height it has to again, and what maneuverable, what orientation it should have. These all things can be programmed automatically. So these are some facilities that we get if we are using the UAVs for photogrammetry. And also the possibility of autonomous flying over the dangerous areas. Over the dangerous areas, we would like to have the manned mission. So now we can configure the drones to go over these areas and then come back safely, acquiring the data as per the design. And the image acquisition modes can also be varied. Now if you see here, this particular figure shows you the data acquisition in the conventional manned mission, where the view is oblique towards the scene, whereas in case of terrestrial, the photography is in this way. Okay, but if you use the drone, the UAV, you can configure it to orient yourself as per the requirement and take the photography, which is basically a combination of the one that you get from the conventional aerial platform and also from the terrestrial. So this way the UAV becomes a transition between the conventional aerial platform and the terrestrial. So you can see here, if you are using a UAV, the photography can be done like this. So this way is the similar one which you do it for the terrestrial, and this is the similar that you do it in the conventional aerial platform. So if you use it, then a mix kind of a done is possible. And if you basically try to look at the accuracy, again when I'm talking about the accuracy, here is the accuracy of the measurements versus the object size. For making the geometrical measurements, there are various tools available ranging from the interferometry to the spaceborne remote sensing. Okay, so on the x-axis, this is the object size or the area size, and on the y-axis is the accuracy with which you can make the measurements. So lesser area, more accuracy you can use for such applications. You can use the ferrometry, and for a bit larger area, for OK type of an is of the order of 10 to the power minus 2 millimeter level of accuracy. For that you can use the industrial metrology or industrial photogrammetry. Okay, so industrial photogrammetry basically stands here. But once we are talking about photogrammetry, UAV photogrammetry is in between the terrestrial laser scanner and the aerial photogrammetry. Okay, it has got both the advantages, so it basically stands in between this. Now once I am talking about the level of details, one part is the accuracy, the other part is the level of details that you get with respect to the size of the object. The size of the object can be same, but the level of details that you want to get may be different. This will be different with respect to the application that you want to have. Okay, something like if you are trying to make a 3D model of a building, you can make the 3D model of a building as the level of detail 1, level of detail 2, level of detail 3, level of detail 4. The accuracies are same. So if you want to look at the data density or the level of details, for very low level of details or lesser number of points on the scene, you can use the CMM method or handheld measurements using the vernier calipers or a normal scale, or else you can also make use of the total station, or you can also make use of the GNSS or GPS for making the measurements. But these kind of techniques we use when we want to get very less number of data on it. If you want to get more of the scene, then we normally employ this either closed-end photogrammetry, aerial photogrammetry, or satellite photogrammetry based upon the area. If the area is more, and also you want to get more detail, more level of details, we normally go for satellite remote sensing or satellite photogrammetry. Okay, and then the aerial photogrammetry, and then closed-end photogrammetry. Now look at where the UAV stands. UAV photogrammetry stands is in between closed-end photogrammetry and the aerial photogrammetry. Okay, so this basically UAV stands as a transition between the terrestrial and the UAV photogrammetry. Sorry, the aerial photogrammetry. Okay, apart from these advantages, plus points, and fascination about UAVs, it has got some limitations. So the first limitation is the payload limitation. So once I want to do a photogrammetry and get very accurate information of the ground, then I have to use a camera which is a metric quality camera, and the metric quality camera are the large format cameras. They are bulky and also large in size. So these kind of cameras which are suitable for the photogrammetry could be ready-madely put on the consumer grade UAVs. In UAVs also there are various grades of UAVs. You might be aware by now. There are UAVs which can lift from few grams to few hundreds of kgs of the payload also. But what I'm talking here is a consumer grade UAV which can lift few kgs. Okay. So for such drones or UAVs, you cannot expect that it will lift a very larger payload, which the camera has got a good radiometry and also the geometric quality of the images which it can deliver. Okay, so we have to get satisfied with the cameras which are inferior, which has got inferior geometry quality and inferior radiometry quality. Okay, and for doing the direct georeferencing, which I will talk in the coming slide, we need to have some extra sensors like the IMU and the GPS should also be there on board the drone. Now these are the extra sensors. If there are extra sensors, then obviously the load is more, which may not be feasible to mount it on a consumer grade camera. So this will be a limitation. If you do not use this pause sensor, which the GPS and IMU will be called as a pause sensor, if you are not using a pause sensor, then you have to depend on the GCPs. But there can be some applications like the application of emergency, like the flooded or the disaster or the hazardous environment where the GCPs cannot be collected. So in such case, it is compulsory that you need to mount these sensors on the drone. So then the payload weight will be more. So then we cannot employ it on the consumer grade kind of a UAV. So this stands as one of the limitations of the UAV, that it cannot lift more load. If it is lifting the more load, less endurance. That is one more negative point. And the other thing is the stability. Once I am doing the photogrammetry, I expect that the photographs are collected from a platform which is very, very stable. It's going, then because of the wind effect, the platform is not stable, so the photography may not be acquired with a more stability. So I can expect a photograph with some blurring. So these blurred photographs are not suitable for doing the photogrammetry. And the since we are using a low quality camera, this low quality camera lens has got more radial distortion, and we can expect more deformations because of the terrain, because we are flying very low. Then the relief displacement will be more. If you have a basic understanding of the photogrammetry, you will understand these terms. The relief displacement, the tilt displacement, these things are going to be very high. And if you are flying very low, then we may need more photographs, and then we need to develop more scopic models, and also we will need more control points, and the images that you get from this low grade cameras will have very low radiometric quality also. So I want a photograph for photogrammetry, very high radiometry and also very high geometry quality, and also it should not have very large blurring effect. So these are certain requirements for doing the photogrammetry. So your drone may not give you this. You, before doing the this UAV mission for photogrammetry, you should ensure that the drone is giving you good geometric image, and also the radiometric image, and also the image should not have any blurring effect. And the consumer grade UAVs may have very short lifespan, so you may need to buy the UAV very soon. And also the UAVs can be used only for smaller areas. If I have to use the UAV for mapping the entire India, then I will not think of a very consumer grade UAV for mapping the very large areas. So for a very small area, for just monitoring a mining site or making a cadastral map of small camp area. So for such things, it is a low cost, and also in case of emergency or a small area, this can be very easily deployed. But for large area, definitely this is not suitable because it has got a less endurance time. The endurance time can be hardly 20 minutes or minutes or 30 minutes depending upon the battery charging it has got. And also these UAVs are not so matured, so the insurance is again one issue. So people are uncertain, and the public restrictions are there, and also the rules and regulations are not clear even in India as of now. Who can fly, who cannot fly? If somebody has to fly, then what kind of rules he has to follow, from whom the permission has to be taken? These things are not clear. However, DGCA has given some guidelines, and it has also released a draft bill. Last year, 2016 March, it has released a draft, and very soon it is likely to make it. However, as of now in India, the rules and regulations are not clear. Who can operate, how to operate? This is some gray area as of now, and it is a bit choking the research in the drone photogrammetry. And the remote sensing expert need to get trained on the operation of the UAV. This is also we can look at as the limitation. If I have a space photographs, I need not worry about how I have to operate. Okay, so the person who has aeronautic experience or a flying experience, they can acquire the photographs with good maneuvering. The one limitation. And the once you are looking for the autonomous flights, you will need some extra the collision avoidance sensors. Once the drone is flying, then it also needs to have the collision avoidance, which can actually maneuver is a collision coming into the picture. Okay, so these stand some of the limitations, and we have also plus things that we can get from the drone once we are looking for the photo. So after understanding the plus and minus of drones for photogrammetric mission, now we will go through the UAV photo steps. So in UAV photogrammetry, we we do the planning. The user itself can do the planning. He can do the flight mission. He can acquire the data. He can get the data. He can process the data, and he can do the decision making. So all this process can be done by the user. So this is one of the best plus point of the drone. If I have to go with the conventional aerial platform, then I need to buy a larger platform. I need to hire a pilot who has got a commercial pilot license, and lot of permission issues are there, and also the flight planning and the data acquisition. I may not to do it, but with the drones I can do everything, starting from the project parameter designing to flight planning to the end product. Everything can be done by the remote sensing experts itself. However, certain training is required for basically flying the aircraft. I think that can be done, but you can experience everything, and you can do the, because a remote sensing expert will be better to understand how the acquisition should also be there. If the acquisition person is not from the remote sensing domain, then he may not acquire the data as per the requirements of the photogrammetry and as per the demand of the accuracy of the project. So this way the UAV provides one more plus point for us. So what project parameters that we look at for before we make the flight planning for the UAV is the requirement of the project, the area of interest, the outputs that you want to get from this, the object type or the output data, and the type of camera that you want can also be chosen. Okay, and the type of model, helicopter or or a quadcopter, these also you can choose. So such kind of flexibility we get here, and also the flying restrictions can also be considered as one of the project parameters. Okay, and once we formalize these project parameters, now then we can go for the flight mission planning. Okay, so in mission planning, basically the documentation of the surface, what we need is a documentation of a surface with if the surface is a flat or it is a moderate terrain, and the exposure of the rough or mountainous terrain like the hazard areas, and the 3D model of the building, whether we have to go for the 3D model of the building or the other objects, these can be considered in the flight planning. So once you do it, then you can also go for the autonomous photogrammetric planning. So in this, the autonomous triggering of the images, you can also configure if the UAV goes here, then the image will be triggered automatically, and also the autonomous takeoff and landing, where it has to take off and where it has to land. All these things can be pre-configured using the autopilot of the drone, and the various functionalities of the camera. Okay, what should be the focal length? However, this focal length should be kept the entire mission as the same. So what should be the camera focal length, and how the camera should be tilted at this particular location, and what rotation measurement has to be collected. All these things can also be pre-configured. Okay, say you are doing a flat mission like this, and if you see a building here, and if you want to make the photography like this, then you can tilt the camera like this and take the photography. So all these things can be pre-configured. So the various maneuvering can also be done automatically before the mission is there, that you can program it, feed it in the autopilot, and autopilot will take care of things. And all these things are not possible in the manned mission. Okay, so once the data is there with you, you can on the field itself, you can do the quality checking. Okay, in the quality checking, you can do the comparison of the data, that whether the data is acquired as per the predefined, and the data accuracy. whether it is matching or not. If there is any discrepancy is there between the designed flight path and the flight path it has gone, and if there is any blurring effect in the image, or if the radiometric quality was not good because of the sun's position or because of the orientation of the drone, if there is any thing that you do not want, then you can assign a new task immediately to the UAV and say that acquired if the acquired position does not fit with respect to the predefined flight path, or else if any image is not acquired over the area, if something went wrong and the image could not be acquired, and the footprint comparison shows the gap, and our required intervals are not fulfilled. If such things are not happened, then the new assignment can also be given to the UAV to go only over that area and then collect this data. And if you find that if there are some intermediate errors in some intermediate results, then also you can ask the UAV to acquire the data immediately, okay, so that you can save the time. And if the quality of data is okay, then you can go for the bundle block adjustment of these UAV photographs, and then you can generate the digital surface model, ortho photos, and also the 3D models can be very easily developed. Okay, so in the flight planning, these are the various parameters that we consider. And for doing the photogrammetry, one thumb line is the focal length of all the photographs should be same. Okay, if the focal length is varying, then we will not be able to perform the photogrammetry. So we have to decide what should be the focal length, where with which I have to mount the camera. Once the focal length is decided, the camera has to be mounted on the drone, and then the drone has to be flown. And what should be the flying height if this is the terrain, and what should be the elevation from the ground, this also can be pre-configured in the flight planning. Now this focal length and the flying height will dictate the ground sampling distance. If the ground sampling distance is very less, and then I will have the better matching between the image, then I will be able to perform the photogrammetry in a better way. So ultimately the focal length and the flying height will contribute something in the accuracy that we want of the end product of the photogrammetry. And also I can, for deciding the camera, I can also look for the sensor size of the camera for the digital cameras, and also I can decide how much should be the overlap. Say this is the flight line 1, so within the so along the flight line, how much should be the overlap between the two consecutive photographs, and how much should be the overlap between the two photographs which are taken from two different flight lines. This can also be pre-configured. Now this is again related with the flying height. Okay, if the flying height is less, then the coverage will be more, and I can have more overlap between the two photographs. And in the photogrammetry, we normally go for the overlap more than 60% along the flight path, and across the flight path it should be at least 30%. This is made sure. But in normally configure it for more than 60% and more than 30% in the front and the side lap. Okay, so this can be worked out. So once person has to work out what height he has to fly so that he get the desired overlap and he get the desired ground sampling distance. And what should be the baseline? Baseline is nothing but the distance between the two exposure stations. Say it has taken the photograph here and it has taken the photograph here again, then what is this aerial distance? So this aerial distance can also be decided. And what should be the distance between the two flight lines? Say this is the flight line 1, this is the flight line 2, then what should be the distance between them so that we get the required side lap overlap between the photographs. What should be the length and width of the area to be covered? It can also go as one of the parameters in doing the flight planning. The average terrain height and the accuracy that you are expecting after this flight. Okay, so this thing is also taken into consideration once you are doing the flight planning. And the velocity of the UAV, how much velocity you want to keep for the UAV, this will be again dictated by the overlap that you want to have, and the flying height. Everything has to be mathematically calculated, and the flight planning has to be again made. What should be the shutter speed of the camera? This will be again clubbed with the velocity and the height. Okay, so the timing between the two acquisition points, say you trigger the camera now, and after how much time the camera should be triggered to take the second photograph. So this timing one can also define. the field of view of the camera, the image acquisition point location, so where the camera has to be triggered to take the photographs, and the additional waypoint. Say you do the photography mission like this, but there can be some extra where you want to take some extra photographs. Okay, so such waypoints can also be predefined. And the definition of line, path and boundaries, this can also be defined. You can also define some no-go areas. Say your area is very large, but there are some areas where you are not supposed to do the photography. Then you can also decide and put it in the autopilot that these are the areas where the drone should not go. And in the autonomous, if it is the case of autonomous flight, you can also decide the start point from where it has to take off and the landing point where it has to land. Okay, so now the once you have done the flight planning, then the flight paths can be varied, and UAV here provides us some flexibilities. Okay, let us look at those flexibilities which are the UAVs is providing us with respect to the conventional aerial platform. So these in the previous slide I told you that the drones are basically forming a transition between the terrestrial photographs and the aerial photographs. Because of this reason, we have some flexibility with the drones. So the modes can be 2D mode or 3D mode of data acquisition and the circle based mode. Okay. So in case of if you want to make a 2D flight path, then the inputs required is simply the map of that particular area or the ortho image or the digital surface model of that particular area that you can get it from the available other sources, and then using these you can do the 2D flight path of the 2D flight planning of the drone. So this is normally done over the flat areas or the areas which has got a moderate variation in the ground. If the in case of the mountainous or very steep areas or where the undulations are very high, just like the Dehradun areas where we find a lot of mountains here, undulation, for such we have to go for something called the 3D flight planning. So in order to do this, we need to have the digital surface model of this area. Okay, so this digital surface model of the you can get from the satellite images. If you have the stereo pairs of the satellite images of this area, you can generate the this DSM, and the same DSM can be used for doing the 3D flight planning of the drone. And this is normally done for the mountainous or areas. And you can also do the flight planning like circular flight planning. Okay, so for this we need the map, ortho image or model of that particular object. So this is normally done once you want to focus on only one object. Say there is a building and you want to take the photograph and develop the 3D model of this particular 3D of this building. Then we for this 3D or the circular flight path. Just like if there is a say Qutub Minar is there, and if you want to make a 3D model of the Qutub Minar, then the circular flight planning has to be made so that the photographs are acquired with enough overlap, and then we generate the 3D model of the structure of a single structure. So in the steep areas, the nadir view would generate the lot of occlusions. If in the steep areas, if you do the 2D flight planning, and because of the small ground undulation, then there can be some areas which are not covered in the photograph, so we cannot be able to generate the 3D surface of that particular area. So for steep areas, normally we go for the 3D flight planning. And also one limitation if you use 2D is the variation in the scale. Say the ground is like this slopey, and if on the ground if you are using a 2D flight path, you take one photograph here and the second photograph here, the scale variation will be very high, and this scale variation if it is more than %, then that is not suitable for doing the photogrammetry. Now I'll discuss about what are actually is a 2D flight path and a 3D flight path. The 2D flight path is something like this. If you have the map of this area, you can see here the line. So from here the acquisition starts. So this is your flight path 1. I can draw it for you. So this is not visible then. So here you can see that this is the flight path 1, and this is the flight path 2. This is the flight path 3. So the aircraft is going only in the one plane. It is acquiring the stereo photographs. Whereas in case of the 3D, you see here this is a 3D surface, and it is this TP surface which is something like this. So on this, if you want to do the or generate the surface model of this area, then the 2D flight path will not be suitable. So what happens is, if you want to do a 2D flight path, then the photograph that you take here and the photograph that you take here will have a lot of scale variation. So in such case, the drone has to be operated along the slope. Okay, if the slope is, if say the slope is like this, then the drone has to take one photograph here, and it has to come down, take the second photograph, it has to come down and take the third photograph. So the drone has to along the slope and take the photograph so that the scale is maintained same. So we get this flexibility from the drone so that we can do the 3D flight path and then get the photographs with less scale variation and with the uniform ground sampling distance. And coming to the circular way of the photograph acquisition, says up you want to develop the 3D model of this particular building. So around this particular building, you can take the photographs at various heights. The drone can be configured to go around this building and take the photograph, and then increase its height, take the photograph again in the circular mode, and then using these overlapping photographs, you can generate a very good textured model. But here we have only, okay. Now, those once you are done with the photography and you are acquired the photographs with the desired flight path and the mode acquisition. Now these photographs which are having some overlap and taken with the same focal length but from different location has used to calculate the ground coordinates. Okay, so now if you look at what is the basic principle of the photogrammetry, those participants who have knowledge of photogrammetry are listening, maybe familiar, but those who are new, they may have good information now. So the we have a camera here, and using this camera we acquire the photograph. So what is how we are acquiring a photograph is we get a light ray that passes through the perspective center of the lens and it hits the CCD array. So once it is hitting one of the CCD array, it is forming a pixel. Okay, if the all the CCD arrays are populated with the light rays, then we get an image. Okay, so this image we have to use that we can do the we have to find out from where this particular light ray has come. That is basically the ultimate aim of the photogrammetry. Okay, but if you use a single photograph, then we will not be able to know from where ground point we got this light ray and we got this pixel value. Okay, for that we make use of two photographs which are taken with same focal length but from two different locations. Okay, so this is the point on the ground, and from this point the light ray that is going in this direction passes through the center of the lens and then illuminates one of the CCD array and you get one pixel here. And similarly the light that is going in this direction passes through this lens center and then you get the second pixel, second image. Okay, now if we send the ray back in, then we will be able to know from where we have got this ray. Okay, if we are successful in finding out the location of this point, then we are basically computing its coordinate and doing the photogrammetry. So photogrammetry basically deals with these two photographs which are having some overlap, and then it performs the triangulation to get the coordinate of this ground point. So this is what is the basic principle of the photogrammetry. Okay, so for performing the photogrammetry we need some information like what was the internal geometry of the camera when the photograph was taken, and what is the location of the ground point on the on the image, and where the camera was the image was taken, and what was the rotation and orientation and attitude of the image was taken. So these information is required, so do the photogrammetry, perform the triangulation and then get the ground point. Okay, so the internal geometry we get by doing the interior orientation. This interior orientation we can do it by performing the camera calibration. So before mounting, they decide that at this particular focal length I will acquire the photographs. Okay, that particular focal length you have to do the camera calibration. So the camera calibration, once you are doing, basically you are defining what is the internal geometry of the camera, Okay, so in order once you are doing the camera calibration, you will get some camera calibration parameters. So the camera calibration parameters are the focal length, the location of the principal point, okay, and also the distortions related to the lens. These are the parameters that you get after performing the camera calibration. Okay, so in order to perform the camera calibration, there are some online open source codes are already available, and using a chessboard and acquiring the photograph of the chessboard from different angles, and using these codes you can extract this camera calibration parameters. So this has to be acquired before you mount the camera on the drone. Okay, so once you acquire the photographs and once you do the calibration, parameters are available with you, you should now look for those points which are common in the two photographs. Say suppose this ground point A was seen in the image somewhere here and on the image somewhere here. Now you should do the image matching so that you can find out the common points in the two images. So if you are basically, if you do the image matching, you will be able to locate this conjugate points. Conjugate points are the same points which are seen in two different images of the point which is on the ground. Okay, and then you have to, once you do after you do this interior orientation and image matching, you have to do the exterior orientation. So for doing this exterior orientation, you will need to take the help of the GCPs. So once you locate some ground control points on the ground and their respective points on the image, just by performing the backward resection, you will be able to extract the location of the camera and also what was its attitude when the photograph was taken. So this can be estimated. So in case if you do not have the GAN, you can make use of the IMU and GPS. Those basically will provide, GPS will provide you where the camera was when the image was taken, and IMU will take roll, pitch and yaw when the image was taken. So using this GPS and IMU, you will get the EO. With EO, you perform the image matching, you will get the conjugate points. With this EO, IO and the image matching points, you can perform the triangulation so that you get the ground coordinates. Okay, so once you are ready with the interior orientation that you get from the camera calibration, exterior orientation, either you take the help of GCPs or the IMU and also you do the image matching. So once you do it, then perform this space forward resection, which is nothing but the triangulation, so that you get the ground control points. So this is done for all those images which you have acquired using the drone. Okay, and if you do it for all the pixels of the entire images that you do it, basically then you will be generating the 3D surface. Okay, that 3D surface we call it as the digital surface model. Okay, so in the flight planning you can also configure what can be your GSD, ground sampling distance. That can be configured by making a value for the focal length and also the flying height. Okay, just by adjusting the flying height and the focal length, you can get the desired GSD. So that you can get it from this formula, and this GSD will also dictate the accuracy, the planimetric accuracy that you can generate. So that you can pre-configure using this formula. Okay, and then you can also visualize if you make some error in identifying a point in the image and the interior orientation, exterior orientation, this is the error that you can get in computing the ground coordinates. Okay, so if you make this angle more, then you are likely very less error. So this will be further dictated by your base to height ratio. Okay, so once you have the photographs, you can orient these photographs by performing the image matching and making the observations of the EVO, and then make some tie points and then generate the and then compute the ground coordinates of the various points. So using these ground points, you can generate the digital surface model, or else you can generate the mosaics. Okay. So with this you can have a 3D surface model, and using this 3D surface model you can also generate the ortho images. Okay, so any photograph that you take from the camera are not ready to do measurements. They have got some errors, and these errors need to be rectified. So after you rectify these errors, we generate an image called orthorectified image. This orthorectified image has got same scale, and these images can be used to do any measurements. Otherwise, a raw photograph, on the raw photographs you cannot do any measurement. So you need to perform this orthorectification. Basically, orthorectification removes certain displacements and the distortions that are created by the ground on the image. Okay, so when you compare this, the distortions or the displacement with respect to the orthogonal projection, normally when you compare the image with respect to the map has got a orthographic projection, whereas the image is basically a perspective projection of the ground, which is something like this. If the ground is like this, then these points, if you are projecting it using the orthographic projection, they will be projected like this. And the same point, if you take, if the same ground, if you take it with the help of a camera, then all these points will be projected in this way. So here this is the central projection or the perspective projection. Because of this projection, the distortions will be there in the image, and image is not suitable for making sense if you do not remove these displacements. Okay, and if you see here, if you do the orthographic projection for cone, cylinder and a building, the on the map it will look like this. But if you take a photograph, the building will look like this, and the cone will look, and the cylinder will look like this. So whatever is this displacement, we call it as this as the relief displacement. Okay. So if you are making a if you are taking a photograph and the image here, you are basically projecting this 3D surface using central projection and making a image. Because of this central projection, you get these distortions, and these distortions need to be removed. Okay, so because of this projection, you also get that the scale variation will be there. The scale is not uniform on the image. The objects which are near to you will have larger scale, and the objects which are farther to you will have smaller scale. So that's how the raw photograph cannot be used for making any measurement. Okay, so if you see these three objects, and if you project it on a map, it look like this. On the image, they look like this. Okay, so this is the relief displacement. The top of this particular pole has got deflected. Okay, so this is happening because of the height of the object. So in order to rectify this, we need the help of the digital surface model that we have generated. Okay, so this process we call as the orthorectification. Okay, so once you rectify this image using the digital surface model, then this image can be used as a map itself. Okay, so in order to do that, we need the digital surface model or the digital elevation model, and the image that you want to do the orthorectification, and also its exterior orientation or the EVO parameters are required. Using these EVO parameters, the image and the digital elevation model, we can rectify this image. Okay, so once you take an image, sides of the building and also the ground. Okay, so your image may have the roof like this. So after doing the rectification, the roof will be shifted, because this was the displacement that happened of the roof. This can be removed by using the digital surface model of this area. Okay, so if you have a raw image, then that can be rectified using a digital elevation model of the same area. If you do not have the digital elevation model of the same area, then you can use these two overlapping photographs, stereo pairs, to generate the digital elevation model, and the same digital elevation model can be used to rectify this image. Okay, so these are certain differences of the raw image and the ortho image. Okay, which I have already discussed. Okay, so in summary, what the UAV photogrammetry is, we do the flight parameters like what should be the ground sampling distance or distance, what is my area of interest, the camera information, flight goal, all these parameters go into the mission planning. And this mission planning can be done by also choosing a UAV platform, pilot, and the ground control system will form a part of the UAV mission planning. And with this mission planning, we acquire the data, and using this data, we perform the photogrammetry so that we get the digital surface model or digital terrain model. And once we have the digital terrain model, we can generate the we can get the features, we can generate the ortho images, we can also do the 3D modeling. So in short, the UAV photogrammetry includes all of them. Otherwise, if it is a conventional aerial platform, then our job is only this much. Okay, or if it is a satellite photogrammetry, then our job is this much. Because the drones we can configure, we can also play a role in this. That's how the UAV provides us the feasibility. Okay, now after understanding how the UAV can be configured and how we can do the flight planning and how we can process the data to generate the digital surface model and the orthophoto, now let us look at what are all the possible applications of the UAV photogrammetry. The first application is whether the UAV can be used for national level mapping. So I'm just discussing this paper, which was by Michael Kramer, which is published in 2013. This paper is basically a summary of the research conducted by European Spatial Data Research Organization. They tried to look at the feasibility of UAV for national level mapping. So this was the work by national mapping agencies of Finland, France, Germany, Switzerland, Ireland, UK and Netherlands. And these are some of the observations that they have published in this paper. So what they feel is that UAV is an optional technology to perform this task, basically to create the national wide the database. And they feel that mapping really can be done only in case of emergencies and for a very small area. And also the mapping of the coastal erosions can be done very effectively, and updating small areas of the digital terrain of known areas can be done very easily. Large scale map updation is possible but not for the larger area. What they also feel is that these drones are useful systems for making high resolution pictures over highly populated areas. You can get very high resolution images which can be made into the orthos further, which can be used for doing the mapping. And the experiments also showed that geometrical accuracies are of the order of 3 centimeters, and it makes the orthophotos useful for using them in cadastral verification of the ownership. And also they feel that UAVs will definitely not replace the traditional airborne techniques, which has got high-end large format cameras, laser sensors. They may not replace it as of now. The level of technology that that the drones have, but if the drones mature further, having longer endurance and longer load lifting capability in future, they may be a replacement for these traditional techniques. But as of now, they feel that it is not. And they also feel that these flying regulations need to be relaxed. And these UAVs are suitable for the applications like cadastral application, land management, land consolidation, and disaster monitoring. And they also feel that UAVs, as they fly much lower height, UAV based products are free comparable with the manned mission or with the ground methods. So another application that we have done is on the landslide mapping, and this case study is on the Kohima highway. This highway is between the Kohima and the Dimapur. The location is here. So if you look at the multi-temporal data, this is basically taken from, these images are taken from the Google Earth to see how this landslide is basically shifting the road. Okay, so if you look at, this is the image of 2014 and this is the image of 2006. So in 2014 the road is here, and in 2006 the road was here. So basically in this 8 years the road has shifted by 100 meters or 200 meters because the land was sinking. So the local authority has to shift this road, and this is one of the major road. Then we really try to look whether we can do the mapping of this landslide with terrestrial techniques is good or with the UAVs is good. So for landslide, we have made use of the terrestrial laser scanner, which is costly, which comes with a cost of around 70 lakhs. And if you are using a terrestrial laser scanner, which is very costly, that gave us the data, high dense data, definitely, but it has got some gaps. However, it is very costly and sophisticated technique. Even with that technique, we could get the data with some gaps or holes. because of the local undulations on the landslide. We are standing on the ground and landslide is there, and if there is any local undulation, these local undulations are blocking the area, so we get the holes here. So even this high-end technology could not provide us a better solution, but when we used this DJI Inspire, this was the camera and these are certain details. So using this 177 photographs, we could generate the digital elevation model with the pixel resolution as 14 centimeter. And here is the digital elevation model, and here is the ortho image of this particular landslide. So this work was in collaboration with Nagaland GIS and Remote Sensing Center, Nagaland. So this entire work from planning to the end product, ortho, was done in few hours. Morning after breakfast we did it, and by lunch we are ready with the end product. Okay, so other possible application is the cadastral map generation for small areas. If you have your own farm or your area, you can very quickly fly the UAV as per the design, and then you can very quickly generate the cadastral maps. The other applications are which demands the higher temporal resolution is the volume changes that we need to estimate over the mining areas. Okay, so morning photogrammetric mission, and at the evening we can have a photogrammetric mission, and then compare these two end products. Then you how much volume was mined. Okay, so nowadays people also use satellite, but they have high spatial resolution, neither they have the high temporal resolution. But UAVs can be flown for every 1 hour also, and you can check how much volume is excavated, and accordingly the monitoring of these mining sites can be done. Other application is the archaeological 3D documentation. What I was earlier, if you want to do the 3D modeling of very tall towers, just like the Qutub Minar, if you take the photograph from the ground, then you have to take an oblique photograph to do the 3D modeling of the top portion, where the GSD will be increased, and here the GSD is less. The 3D model of the top portion cannot be very easily or comfortably done with the conventional terrestrial photographs. But if you depend on the conventional aerial platform, it only gives you the top view. But if you make use of the drone, you can operate the drone in both circular mode and also in the vertical mode. Rotate this drone in a circular mode and increase its height, so that you have the photographs with the same GSD but at multiple heights. So even at the top portion, you can generate a very good 3D model. So the 3D documentation of such long or a single object can be done very nicely using the drones. So this is one plus point where we have for the drones. Okay, so other applications in natural resource management is in forestry and natural conservation. The forest inventory like the tree height, crown diameter, biomass estimation can be very easily done because you can fly very low. Forest fire detection and prediction of the forest fire can also be done. Monitoring for illegal restriction and evidences in case of violation and infringement can also be collected. Locating harvest sites and inspect pest operations, that can also be done. Monitoring and change detection within best where trespassing is difficult or undesirable can also be done with the drones very easily. So this was reported in this particular publication. And in agriculture, the UAVs can be used for doing the flight trials or for the research purpose. Determination of the biomass, crop growth, and the food quality, these assessments can also be done. And nowadays people are talking about the precision farming, basically to determine the degree of weeds and site specific herbicide application. These drones can be very nicely used. Nowadays people are also using drones for sowing the seeds and also for spraying the specific fertilizers. Drones are being used. One more recent application and the immediate societal application that you can see with the drones is the crop insurance. Nowadays we are talking in India, the Pradhan Mantri Fasal Bima Yojana is now very much into the society, where the direct field estimations have been made, and the farmer has to be ensured that he will get so much amount once he insures the crop. So in this particular Bima Yojana by the Prime Minister, it has been made one of the mandate to use the drones to make the assessment that how much will be the possible yield and accordingly the insurance company can monitor his crop and then pay him the insurance in case of any disaster. Okay, so the other possible applications are the flood inundation. If there is any flooding, then very quickly you can deploy the drones and then assess how much area is flooded. Okay, and also for monitoring. So as we all know that rivers get some sediments and they deposits whenever there is a flat slopes, and as it starts depositing the sediments, it will change its course of direction. Some landslides in the nearest area. So now the people has to monitor the course of the river, and the accordingly the mining of the sediments should be done so that the river is maintained in its original path. One can use the drones and acquire the data because it is a very small area, and multi-epoch data can be acquired, and he can suitably locate the zone where the sediment mining can be done. This is one of the application that one can have. Another thing is site suitability analysis for infrastructure development, like construction of a dam, 3D city modeling, various civil engineering applications like planning, excavation work, cut and field work, construction of bridges. For these applications, the drones can really play a major role. And also for urban monitoring, maybe for traffic monitoring or monitoring the urban infrastructure development, whether the people are following the local regulatory norms or not. If somebody is violating, then accordingly the penalty can be imposed on him by with using the digital evidences. And also for monitoring the border area surveillance, these can also play a very good role. So the application list goes on, and I have only given you some of the list of the application which can be very quickly done. So these are much for being with us.